Hi there. Okay, we're going to take a look at the first two exponent laws. So in your powers and exponent booklet, let's go to page 14. Okay, and we're going to put the actual shortcut law inside the box, and then we'll write underneath and do some examples. Okay. So the first one for the product law, it says a to the m plus a to the n equals a to the m plus n. Okay, so I'm going to have a to the m plus a to the n equals a to the m plus n. And I'm going to color code this stuff just to make it visually even easier to see. Okay. Okay, so if we're looking at that, so what this says is that when you multiply powers with the same base, you add the exponent. Okay, and I'm sorry, I don't know why it said plus, that is multiply, okay? It has to be multiplying, it can't be adding, okay? So let's take a look at an example here. Okay, so if we have 3 squared times 3 to the 4th. Okay, so if I look at this, I have the same base, okay? And if I take a look at my exponents, I have a 2 and a 4, and so I'm going to add those together to get 6. Okay, so if I were solving this equation, I'd have 3 squared plus 3 to the 4th, okay, equals 3 to the 2 plus 4 equals 3 to the 6th, and then I could solve it, which would be 729. And if you're like, Miss Lavia, can I just skip and solve? No, okay? This is what I need to see. I need to see that you know that you're adding the exponents and then what that product would be, okay? Or what the sum would be, okay? And then you can solve. Okay, so let's try another one. So if we have negative 6 squared times negative 6 cubed, what would that look like? Okay, well, they have the same base, so then we would have negative 6, 2 plus 3, negative 6 to the 5th, okay, and let's see, negative 6 to the 5th, that is negative 7,776, okay. And remember that if you're using an exponent that's not squared or cubed, look for the y to the x button so you can make it whatever exponent you want it to be, okay? Okay, so that is the first law, the product law, and the next one is the quotient law, right? So we know that when we say find the quotient, we're working with divided by, okay? So same thing, I'll color things in here. So what we're saying here now is that when we have when we divide powers with the same base, we want to subtract the exponents. Okay, so for example, if we have a to the m divided by a to the n, that would be the same as saying a to the m minus n. Okay, that's our little shortcut, okay? So, and if I write that out in words, when you divide powers with the same base, you subtract the exponents. So let's take a look at example. Let's look at 3 to the 4th divided by 3 squared. Okay, so that's the same thing as writing 3 to the 4th divided by 3 squared. Okay, I'm going to put here same as. Okay, they both mean exactly the same thing. Okay, so if I were to look at this one, I would have the same base, so I can go 3, and then my first exponent is a 4, and the next one is a 2, so I'm going to get 4 minus 2 in brackets. 3 to the 4 minus 2, 4 minus 2, that is 2, so that would be 3 squared, which would give me 9. Okay, and that's the same thing as saying, if I write it out this way too, I could have 3 times 3 times 3 times 3 divided by 3 times 3, right, because 3 squared. And then I can cancel out the common numerators and denominators, which also leaves me with 3 squared, which also leaves me with 9. Okay, so this is just an extra step, and I guess a visual that can help make more sense of it. If you're like, I don't like this very much. Let's try one more. Okay. Let's try negative 5 to the 6th divided by negative 5 cubed. Okay, we have the same base, so then we can subtract the exponents. So we'd have negative 5 to the 6 minus 3. Remember, these are supposed to be smaller numbers. They should look smaller than your base. So that's going to be negative 5 to the cubed. And because we have the negative inside the bracket, when we have an odd number of exponents, that's going to make our answer negative. And 5 cubed is 125, so negative 125. Okay, so that's each law kind of put out separately. Now let's try a couple questions with them together. Turn the page. Okay, here we go. So all we're doing here is making sure that we do things in the correct order. Okay, so if I'm looking at 2 squared times 2 cubed divided by 2 to the 4th, so I'm going to do the multiplying first and then the dividing. Okay, so I'm going to do my multiplying first. I have the same base, okay, so that's going to be 2 to the 2 plus 3 divided by 2 to the 4th. Okay, and when I simplify that, I get 2 to the 5th divided by 2 to the 4th. Now I can subtract my exponents, right? Okay, so I'm going to have 2 to the 5th minus 4, which is 2 to the 1. And anything to the power of 1 is just the base. So there we go. Done. Okay, not that bad. Next one, we have another one here using 4s. Again, we have multiplication first and then division. You should try this one first and then check your answer. Okay, so again, we're going to do this first. So I have 4 to the 1 plus 3 divided by 4 squared equals 4 to the 4 divided by 4 squared. And I'm color coding this just to make it easier for you to see. That's all, you don't have to do that. Now if we're dividing, we're going to subtract our exponents. Okay, so I'm going to have 4 minus 2, which gives me 4 squared, and 4 squared is 16. Whoops, sorry. So if you're like, I never know which one, if I'm dividing, do I add or subtract my exponents? And I think about it like this. When I'm dividing, okay, I have like kind of a hidden minus sign inside there. So when I'm dividing powers, I'm going to subtract the exponents, okay? And when I'm multiplying powers, okay? And then I just rotate it a little bit, okay? Gives me a plus. I'm gonna add my exponents. So that's kind of how I try and think about it, if you get confused. Okay, I want you to try those 3 questions. Right on, off you go.